As I talked about earlier, this session will be going over, or as I posted on Slack, data structures and algorithms, applications of stacks. So there's the stack data structure, which I think we've all at least heard of or probably encountered. And as always, I have sort of 3 example questions that we can go through out to practice them and how you might encounter them in these sort of DSA, data structures and algorithms, interview questions. So first of all, what is a stack? Who can volunteer? Okay. I know, now it's like, oh, okay.
It's just a stack is a data structure that usually takes input of first in, last out. So the common example for that is like a stack of pancakes. I don't know who eats pancakes like this, but you get rid of the pancake on top to get to the pancake right underneath that.
Yeah.
I usually just cut the wall out of it, but.
Yes. An example I've heard is like, in food courts, sometimes they have like all these trays that are on sort of like a spring, so you take one tray off. So that's more understandable. But yeah, so just like Darnell was saying, you have some stack, and there's sort of the top, and there's the bottom. And as you might sort of imagine, if you're making pancakes, you can only put them in this order. And then if you eat them in sort of the way that these books want you to, you then start consuming from the top down. So the oldest pancake is on the bottom, you might say. And that is versus a queue where, it's sort of like a queue, is I guess the British word for line. So, your queue for the bank, the first person who got there should be the first person, helped by the teller or whatever, and then you go back. So that's the opposite. So I think a natural question is like, well, we have stacks and we have queues and we have these other data structures like hash tables and arrays and other things. And this one seems really restricted in the sense of like, okay, you can add you can either push down or pop. And like, you can do that with more sophisticated data structures with basically the same amount of time and complexity. Like why would we ever use stacks? So I sort of gave a hint in the Slack announcement. People want to try to volunteer ideas of like, oh, here's where a stack would come in handy. All right, let the record reflect. I'm goading people for questions. Yes.
So for the checking if we have matching parentheses, for instance, or you could think of it as our text editors that are able to tell us if we have matching parentheses or matching curly braces. It's good. This is a data structure that can help us keep track of if we see an opening in parentheses, we want to make sure that the next thing that we see is a closing parentheses.
Yeah, so I think you're talking about stacks are really useful for this pretty well-known question of how do you keep track of matching parentheses. So here, as I think you were talking, here's an example where we have some function foo, and it takes 4 parameters, a, b, c, and then the result of the function bar. Bar itself is a function which blah, blah, blah. And open, open, close, close. And you can imagine that there's some weird situation. The simplest sort of error would be foo. I said, oh no, this is not matched. That's a typo. And yeah, so stacks kind of lend themselves, so that, when people say, oh, what's an interview question about stacks, a very common one is, oh, keeping track of matching parentheses. And that's the first one we're going to go through today. But yeah, there's this idea of, you want to remember, I've seen 1 parentheses, I've seen 2 parentheses. Oh, I'm putting them on my stack. And then, right, when you see a close, you want to say, okay, that close is the most recently seen one. So it's not that you can't use an array, with kind of keeping track of the indices in certain ways. It's not that you can't use an array directly to solve this problem, but a stack just really captures that idea. Is that somewhat persuasive? Yeah. Okay. There was many nods. I say to the camera. Everyone was shouting. I guess. Hello. Yeah. All right. Forehead. I'm trying to figure out those. And it's sort of, if you group if you Google things like applications of stacks in real life and that sort of stuff. So I promise there really are a lot. But there's the explicit data structure, and that's where you think, okay, let's start pushing on like the character or the string, open parentheses, and popping it when we see it close parentheses. But for instance, when you call functions, right? If you have some function, a different function foo, and that calls a function bar, and that calls a function baz, right? You've probably, I hope you've all done this a lot with debugging, because we all have to debug. But right, there's this idea of like, well, we have to finish executing baz, and then we go back to bar, and then we finish executing bar, and then we go back to foo, we finish executing foo. And so again, there's that stack idea. And in fact, this is called a call stack. And if you ever, you will see countless times, there's some bug, there's like a crash in your program, or some error being reported. And the first thing it'll do, or one of the very first sort of starting questions is, what was the call stack? Which is sort of something that's easy to, for the system to provide, of saying like, well, the error happened somewhere in baz. Baz might be called by many people. So, okay, baz called by bar, called by foo, and you start being able to actually kind of see a little bit of like, okay, here's what the execution was doing. For debugging, there's a lot of sophisticated stuff too. But again, just kind of knowing, it's not that, oh boy, you need to implement this call stack stuff, but it's like, okay, that's how it works. And if you start using a debugger to like step through things, you have this, there'll be this idea of like pushing and pumping. So it's not so much that like, oh, you need this explicit data structure as implemented in a certain way, but that it just captures this thing that comes up over and over again. The last one is arithmetic expressions. If we have 1 + 2 × 3 + 4. Again, this sort of comes up in compilers, but in a less direct way than you would match parentheses. This is usually, the compiler usually keeps track of these sort of arithmetic expressions in the form of a stack. I won't get into the details because I always get turned around. But I'm just, again, I promise that this stuff really does come up. That's my pitch. So that's it. That's stacks in the most abstract sense. Is anyone suspicious? Does anyone have further questions? Are there comments on the call/television? I don't know if that's.
Nobody has one.
Okay. I'll just set this as my phone background or something. Watch myself. So that we've talked about in the most abstract sense. And that's at a sort of hand wavy level. Let's say we have some struct, or probably I'll use the word class, sorry. Class, stack, kind of what methods should it provide? What API should a stack provide in the simplest sense? Sorry? Oh, just like I've been talking about stacks, it's this idea of thinking about pushing and popping and so on. And I guess I've been going a bit in a circle, but like, okay, these practice questions we're going to really do concern with explicit data structure called a stack that captures this idea where you can put things on and take things off in a certain order. So what's like the bare minimum methods that a stack implements?
Push.
Yeah, okay. Is that someone surprised by that or any suspicion? Okay. So push, and it might take a character, like a letter, and pop, which generally, returns. So this is sort of C or Java syntax. So it takes push, or it can pop. And that's it. You have to be able to build a stack and so on. And most other languages, or most languages, if they have like a stack library or a package, they'll have things like size or like is empty and other stuff. But and those will probably be useful in real questions that involve stacks. But if someone says, oh, let's use a stack instead of something else, they're really talking about this interface. So it's just two methods. Nice and simple. So, and I'm not going, way back when there was a different workshop where we talked about how we might implement the innards of this. We're not going to do that today. This is going to be sort of, a colleague has provided us a stack library that we're going to use. Did anyone, I know this is usually no. Has anyone had a chance to look at the questions that were posted on Slack? Okay. Mostly no. And I got them out late this week, I know, as well. But we can start with a sort of quintessential question. So I'm going to jump right into the questions. Are we good? It's a little toasty here.
We can open the window if you want.
Oh, wow. Ooh, can I?
It might be.
Ooh, spring loaded. All right. I hope it. Like, if you're all cold, whatever. I'm sort of overdressed. Let me know.
I have the jacket if anyone.
All right, fair. So the simplest, or not simplest, but like, sort of, if you Google interview question with stacks, you will get the matching parentheses question. What that is we have some string. String is some parentheses, like this. So this is, it's a string of length 2, right? And it has, the first character is the left parens, or the open parentheses. The second character is the right parens. And the idea is that our function will return a Boolean, true or false, matching parens, and it'll take a string S. I'm sort of going to make up syntax a little bit. I didn't have time to write it out in Python. Okay. And it will return true if these are sort of valid. So to make sure we understand the question, let's talk about, and to test our to-be created implementation, what are some test inputs that we might want to consider? So it's going to be of type string. What are some strings that might be interesting?
Empty string.
Yes, my favorite is the simplest input, the empty string. Or like, the empty list if it's a different question, or the 0 or 1 or whatever. Yes, that's great. What's another example test input?
String of integers.
Okay, so sort of like bad characters, you might say. Like ones, okay, so I'm just going to keep that simplest one, A. And so I definitely like that, especially in like the real world, where you can't trust anything in terms of input. But for the sake of the problem, it's just, okay, we'll deal with this case and not. But for the rest of our tests, let's just worry about parentheses.
So one parenthesis, one open parenthesis.
Okay. Oh, and actually, I should have started this. What do we want the result for the first input to be? True or false?
True.
Oops, I think there's a discussion to be had. So I guess, oh, sorry.
I'll say false because we're checking for the validation of the parentheses.
Yeah, so there's this intuition of like, well, there's no parentheses at all, so there's none that are matching. For what it's worth, I usually think sort of the other way. It's not like, oh, this one's right or wrong, because it is sort of, the real answer is it depends on what you want to use this for. Generally, I have found it is sort of, most people seem to expect like optimism. So like, oh, if there's nothing, then great, they match. Like return true when you can, sort of thing. I never want to say that's always going to be the case, but often enough, it seems that that sort of leads to a simpler implementation, because as we all know in low recursion, you might say like, oh, the simplest, you want to build up the valid cases, balanced parentheses, and the simplest one is the empty string. I know that's a little bit vague. That's some justification of why we might want to have the empty string be true. But it can be false too. But here, because I'm holding the marker, we're saying it's true. And so on. What should we do for A? Okay. Thank you. Oh, okay, I guess that's also fair. It's like, well, the empty string's true, what about A? Again, I'm holding the marker. Just gotta make a decision. All right, this one though, what should we do for the open parens? The string of just the open parens. Does this string have matching parentheses?
Matching paren.
Yeah, okay.
Yeah, I would say it's false because we found one pair, but we don't have the other one. That will make it a matching.
Yeah, one of the pair, I guess. Yeah. So I would say this is false. And that I think is just the nature of the question. So what's another example input? And what we would want for our result. So like this. And what would that, you sort of said it in the name? Yes, sir. And how about 2 more examples? I'm not thinking of particular ones, but I'm wondering if we'll think of them. So like this?
Yeah.
Okay. And yes. And one more, just for fun.
Maybe alternating different kind of parentheses, so like regular one and the curly brace one.
Oh, I see. So something like this. And so that's the question that I posted. Right now I'm actually just talking about, but whatever. But yes, in the future this will, or I'm jumping ahead, true. But I'll comment that out.
If you have multiple parentheses, they're odd.
They're odd? I just understand.
They're odd, so we have open, open, close, close, close.
Ah, okay. So like, it starts out looking good and then it goes bad. Okay, as well. So I gave that away, but false, I guess, right? Okay. So these are all, and I think, I know I harp on like test inputs. That's useful when we're done with an implementation. And also I think it kind of helps. It's a nice way of, it might provide insight of like, oh, how we might actually want to implement this. Sometimes if you think, if you had no idea where to start with this, just thinking like, oh, okay, what do I want to deal with, might help, kind of open some doors in terms of tools you might want to try to use. And I will just provide one more input back. I'm holding the marker, false. So if we're saying, I understand we're televised, if anyone's comfortable coming up, you're more than invited. But how would we, does anyone have any insight of, or ideas they want to explore in implementing this now that we are armed with our test input? And we know there's going to involve stacks, so okay. Conspicuously not making eye contact with me, so we'll,
The only thing I think about is you want to implement a stack that's async, at least for my language, implement a stack that's async character. But I know we're going to probably do this in Python, so loose that's going to be.
Yeah, so all right. Certainly, I like that starting off. Yeah, I'll just go back in. Yeah, so that's fair. And so you said implement. I just want to drill into that word a bit.
You want to create an instance of stack.
Yeah, okay.
So it's going to be stack, and then basis character equals a new stack. Well, stack, and that equals a new stack. And new base.
So, this is again something I'm sort of making up syntax, but this is the Java way of saying, I'll let you decide.
Yes.
Oh gosh. We have some S, which is a new stack that is designed to hold characters. Okay, so we have a stack, and this is going with the idea, right? We have some string, which is a list of characters, really. You want a stack to hold some of those. Let me just consult my notes briefly. Okay, sure.
Actually,
I think the names will conflict because you call the string S. Stack
it's stack.
P. Because S can, yeah.
So
Yeah, in fact, that's what I did too. In my,
the next thing I did was iterate through the length of the string.
okay, so can you explain, maybe this is sort of too straightforward a question, but why would you want to iterate through this string?
Well, because I'm looking at each character to see what it is.
Yeah. So as in, I hope none of this, if anyone's surprised by this, let me know. But I think that this is these are pretty straightforward steps of setting up a problem where it's all right, we know we want to look at every character in the string. And we know we want to, maybe cheating a little bit, but we know we need a stack, because that's what the question asks for. So let's make a stack and let's go through the string. So we have a I is less than string dot length plus I. And then I might shield and say, we have a character C, which is S sub I. So again, this is just, and I know my semicolons look like J's, I'm trying.
I think that's the same thing. I think there's we do it in Python, but I don't know if JavaScript has char at. So you know.
Oh, so there's like, or we get an S up char at.
Index.
Yeah, sorry. Some languages treat strings exactly like arrays of characters, and others, I guess, are more object-oriented. Okay, so Darnell set us up I don't even know the term. Like, all we have to do is hit it out of the park. So we can, let's start. So, I do like to say that, okay, this is the simplest input, the empty string. But let's start with this input of just like, what's the simplest thing that we kind of know we want to do something and that we know is going to work. And that will hopefully give us a skeleton. And then we can fill out some of the harder or the more interesting stuff. So let's say this is our input. So if I may, so we won't go with code yet, but I'm trying to think of kind of what's the most general way of talking about this.
You want to check to see what the value of I is.
The value of C, right?
SE. Well, you want to, yeah.
See what, okay.
So you start with the value M, but you want to check to see what the value of C is, yes. The way I looked at it, I just thought about one brackets, so we could just do one type of bracket, the opening parenthesis, and we're going to check to see if C is equal to the opening parenthesis. But you have to, well, for my language, you have to make sure that you specify that it's a char. It's not like JavaScript we use double quotes or single quotes.
All right.
Single quotes. So you should just do this in Python.
Sure. If
Yeah.
C equals,
The C equals C is, yeah. Then you want to push that onto the stack, because right now the stack is empty.
okay, and I realize we're jumping into the implementation. Maybe I should take a step back. So I like that idea, of course, of let's push C onto the stack. So does this syntax look natural? Of just like, hey, if C is this, we're going to push C onto P.
It's almost it.
Okay, and so, okay, like, great, we're putting stuff in the stack, and maybe we have intuition of what to do in other cases. But I want to take a step, I should have taken a step back earlier. Is that okay, kind of, make sure we're all seeing that, okay, we know where we're going with this implementation. So do we feel comfortable knowing, okay, how are we actually going to use the stack to solve the problem? I think I sort of skipped that step. I'm trying to read minds, and it seems there's a few bits of hesitation here and there.
Well, you're asking if we can see how we're going to use it to solve the problem, but I haven't seen the problem.
You haven't, well, the problem is to implement, by problem, I just mean to implement matching parentheses. So as in, like, oh, I'm jumping straight into code, and Darnell is helping, or I'm making Darnell do it. But I guess I want to make sure, like, okay, we're talking about pushing things on the stack. It's like, hold on, do we all have a sense of why we want to push something on the stack, and what we're going to do with that later? Because we should do that before jumping into implementation. Oh, sure. Yeah.
Well, so to my understanding, we're pushing like one of the parens onto the stack because we want to pair it up and match it later. as we're iterating through.
Yes.
That's what we're trying to do, right?
Yeah.
Okay.
So I've seen,
Because I've seen this problem solved in a different way, where it was being placed in an object. And then they iterated through the object and paired the rents that way.
I've also seen that. It was like an earlier.
Yeah.
okay,
That's not great.
what, oh, all right, this is even more confusing then. What do you mean by iterate through an object? I don't think I'm familiar with that.
I think it was like they keyed into the object, so like they would, what they did was like they had like a pair of parentheses there, and they had the keys numerated, and then they held each of the parents in like all the keys in order,
Right.
and then to get them back correctly, like I can't remember what they were there, but that was like one of the first DSA questions I got, and that's with me.
But that was that was matching parentheses, but it was parentheses, curly braces, and square brackets.
Yeah.
And it's just that instead of the if saying if C is an open parenthesis, or C is an open square bracket, or C is an open curly bracket, you just put those in a hash table, and you see if it's one of these. If it's,
Okay. And then you increment a counter,
Yes.
and then you decrement a counter when you see and that works?
It worked when we ran the code work.
but you still need a set.
That's just those keys.
You still need a
You
set.
still need it, yeah.
So you guys did use a stack for this?
I guess,
I
but
know I'm asking you to memorize like a year ago, so.
it's a little bit different, but.
So you,
I think it's that this one is actually a simpler version of that problem.
Yeah, I agree.
That
Yes,
we're only
better.
doing parentheses. So maybe
I don't understand the hash table part. Oh, well, let's go on a magical journey and find out together. All right, so is it true that everyone is familiar with this question before, or? So, okay, so all right. I guess I'm rusty from last week. But yes, so I'm to solidify the intuition that I'm glad we all have because I sort of neglected it at the beginning. There's this idea of, we have some stack over here, right? Let's say this is our very big input. And in fact, let's make it a little bit more interesting. So the idea is, oh, we see this stack, or sorry, we see this parentheses, and that's sort of a promise that, okay, we want to match this to a closed one later. And then immediately we see a closed one, and we say, oh, having seen this, having seen this closed one, we've accounted for it and it's done. So it's gone from the stack. It's just capturing that we did. Then we see this one. Then we see another one. So now we have two things on our stack. Then we pop this one, and we pop the one we just pushed on exactly to capture this intuition. And then we see this one, and we pop this one, and now we're back again to empty. And then
So
push.
as soon as you get the pair, you pop them off the stack?
Yeah, it's almost like this is sort of like a to-do list where it's like, oh, having seen this, going over here, having seen this open parentheses, I know I should record it to finish later. Finish. And then, oh, here's this closed parentheses, that means I've finished, just the way the parentheses work, I guess. We say, okay, we finished the most recent one.
So how do you test for like the extraneous use cases, like in the final one, we started off with a closed bracket, or if you had too many closed brackets, how do you like?
Yes, so that's a good question. So okay, if we've all seen this before, or is anyone suspicious of my explanation of our intuition there? Okay. We really got to get one of those like buttons. They have these like voting things where everyone can sort of know, like really big lectures I've heard at. Anyway, so if it's this, we push it on, and this is really just saying, let's remember this to-do list. Then else if, it might vary for your language, but else if C is equal to close. One question, do we push this on?
No.
No, yeah, I know, conceptually it's sort of like, let's push it on the stack, and then it sort of cancels out. Like, nope, we do it much more explicitly of just p dot off. And then, how do we know, so there's still your question, AJ, but how do we know in like this case versus this case? How do we make sure we return true here and return false here, having done this loop? And what's our success condition?
Stack is clear, there's nothing else to pop.
Yes, so I completely agree. It's, we have accounted for all of our to-do list, you might say.
So stack is in.
Yeah, exactly. So return, okay, great. Return, p dot empty, or p dot size equals 0, or there's a lot of ways depending on your language, or p equals the empty list or something. But so great. So that what are we doing?
But that still doesn't cover my question. My question
Yes.
is more of like,
So what happens with this input? That's your question, right?
yeah, what if you start with that, or if you start with an open, but you have too many closing brackets?
Yes. So for brevity, let's start with this one first.
Yeah, sure.
And so right now, so basically what you're saying correctly is that we have a bug.
Yeah.
So if that's our input, what'll happen? Make a new stack. So far so good. This is a bug, just so you know.
Okay.
And then we're going through the whole string. So how big is the string?
1.
Yeah, okay, so this will be quick. The character is the closed parens. So we go here, call pop. And what do we know about p right now? Like, right here, right before we pop, what does p look like?
No, it should,
Oh,
it should be empty.
everything, yeah, because.
Please empty.
Yes, okay, we have a quorum. Yes, at this point, we just we've never gotten to this line for this input. So we pop an empty stack. Depending on the stack's implementation, that might crash, that might do nothing, that might do anything in between. But,
They
it's not
usually have another conditional where it's like if p,
yes. Or, go on.
yeah, else if p is equal to null or something like that.
Is empty,
Yeah, is empty.
or should make it consistent at least. Empty.
And c is equal to the closing bracket, then and null or something.
Return false.
Yeah, return false, return.
Fine. So yes, I like what all of you are saying. I'm just,
Okay, I see how you did it. You did the first thing. The else is in the first part of the conditional, and then you did another. Okay, so.
yeah.
Okay.
So there's, and this is saying, this is to, so I've done this problem a million times. This is this way I've settled on of, it's capturing this idea of, okay, and there's this fancy word called state machine. That, okay, there's a couple nods. It will often look something like this, where you kind of go through a whole input, and then for every single thing of that input, you kind of do one small action. I know that's pretty informal. There's a much more, dramatic way of phrasing it all. But the point is that it's kind of nice if you're doing some pattern like this, where you're going through each element of a sequence. It's usually nice, and you care about exactly which kinds they are. It's kind of nice to have those be the overarching ifs. So like, here's the if, and then here it's like, okay, in the case that the next character is this, we want to do maybe one of two different things. So here I'm exploiting that when we hit return, we leave the loop and everything. So we're never going to pop illegally. But this is also actually up to your other example of what if we get like a weird character, which that would be homework. But that's hopefully people see how to extend to that. But otherwise, this solves the problem. So this is the answer for the single parentheses case. Now, having gone through all this, and I didn't realize that you had all seen this much before, there's a much simpler way of doing this for when there is exactly only one kind of parentheses. And this is just like a neat trick to know. And it's one of the, I don't know if it's such a good interview question to say okay, what's a better way of doing it? Because it feels sort of like you either spend a long time and then it comes to you, or you've heard about it before, or you're lucky and it comes to you easily, or quickly. So here, so to plant the seeds, here we care if P is empty, which we might say the size is 0. And here we care if P is empty, which is the size is 0. And otherwise, when we push something onto it, we increase the size by 1, and when we pop, we decrease the size by 1. And we know that we're dealing with, because of our if statements, we know that we're looking exactly at these kind of parentheses. So do we need a stack to remember, like, the stack is always just going to look like this. So do we need a stack when we know we only have one type of parentheses?
You just have that counter.
Yes, that was it. So do people see that sort of, that jump? I think it's a big conceptual jump to go from like, oh, we just need to count this. We're just using the stack to keep track of how many open parens we see. And it's like, well, if we're already being very careful, like this is an open paren, so let's push the stack, we can just say, well, by a different color. We just have some, X. Does that even show up? Yeah. All right. So there's an X over the V. And then here we have, X plus plus. Here we have X minus minus. And this is the condition of is X equal to 0. Okay, you can zoom in. And so that's sort of I feel a bit of a trick, but it's neat to know because a stack is a pretty simple, like and lightweight data structure. Like an integer is nothing. So
The whole point is to get to 0, and then you just have to compare if you had 0 or not.
yeah, exactly. And it's sort of the stack. If it only contains one kind of value, it's like, well, you're just kind of counting stuff. So we might as well just, as we had all figured out. So now that you all are excited about using integers instead of stacks, let's see why we might have to use a stack, I guess, in the question you've already seen before, of not just one kind of parentheses, but now let's uncomment this. And we want to deal, I guess we didn't go through our input, but I promised that this modulo typos works. So now let's say we instead have, so there's still, and sorry, AJ, to your earlier question of like, okay, there's this troublesome input, and then there's ones where we kind of have too many closing parentheses. Stare at this long enough, and you'll see like, okay, this basically, by the time we're done with these 4, we'll be in the exact same state as if we had started with just, okay, so great. So with these sort of entry, we just had one nice simple kind of parentheses. I'm just going to erase this. And just to make it very clear, here's some, okay, here's some other input that we have to deal with. Now we have to make sure there are 3 types of parentheses that we want to match. So obviously this won't work just in the sense that like as it's written, or it would return true on this input because we wouldn't push anything onto the stack, even though it's an unmatched curly parentheses. So do all of your languages, I forgot to look, do all of your languages have switch statements?
Yeah.
Have any of you used switch statements because they're a little exotic?
Not all
Okay, a bit of a mix.
So you want to use a switch statement to take the input and check against the different outcomes that do something?
Yeah, I mean, a switch statement is sort of a different way of writing a lot of ifs, roughly speaking. It is. And actually, let me just think. I'm gonna get through this one. Yeah, okay. I wish we had a taller board. But I think, sort of to make sure that we're covering new material, we'll talk about this problem using a switch statement instead. So I'm going to erase this. So first of all, I guess I'm jumping ahead a lot today. we had the stack that can hold characters. We used it for the single parentheses, the single kind of parentheses case. And we had this skeleton of like, okay, we handle the open, then we pop the close and so on. Do we believe that that's sort of, I hope that I can convince you that that's, in this case, we can sort of take the simpler idea and extend it to the more complicated one. Not always the case, but we're still going to build off of that skeleton for this question. Using switch statements. So how do we write a switch statement? That's fair. Okay. So I don't know, I guess this is generally programming language education all the time. So I don't think Python quite has this, but it's very, very common in C and C++ and probably Java because it's influenced by it. JavaScript's influencing it, blah, blah, blah. It's weird. And it varies from languages to languages. I think Swift kind of rewrote it in a certain way. But syntactically, so now I'm, comma, C language, sort of, comment. You would write something like, is this showing up? Oh, sure. Switch of C. So this is not too different, saying like if, but we're not doing a comparison yet. And what you would write, a better marker, I guess. Case, and just open paren, or just to keep with what we were doing before, p dot push c. And then the switch statement closes this. So is this ringing a bell? I genuinely don't know what you guys have encountered before. So stop me if anything sounds crazy.
I'm sorry, just do that.
No, stop me if anything sounds crazy.
The switch.
Oh, sure. I know, I'm sorry. I was like, oh, my stand-up career is going to be launched through. Yeah, so a switch statement, its idea is saying, hey, we have some thing, in this case C, and it can take some values, and we care about a few of those values, but kind of more than you'd want to use in a state. So in fact, just to make it, sorry. So in practice right now, this is more or less saying, if C equals open parens, do this stuff. And for C and other languages, then what you would have default in C, and in other languages it might be something else, it's sort of like the else statement. For every other value, go here. So we might want to, return false because we've seen an A as our input or something. That's not a matching parentheses. Or it could return, or we could have something like return if the stack is, or we could just do nothing even. Let's just care about the parentheses and not care about the things in the middle. And what's weird is that in a lot of languages, there's this notion called fall through. And what that means is that if we have this input, or starting with this input, C is that open parentheses, and then what we do is we dutifully push C into the stack, and then we fall through to the next instruction, which is return false. That is not what we want to do, right? But that's just sort of, so what, syntactically? I know I'm teaching you C, but this will come up, I promise, one day. You write break, just as if you're breaking out of a loop. But you're not breaking out of a loop, you're stopping a switch state. I think Swift is the other way around, because I looked it up once. You have to write fall through, it makes more sense. You write fall through and you fall through instead.
I've used return for switch statements. So if we have certain cases, for example, if it goes to case C, then you could put return instead of break.
But would return leave the switch or would it leave the whole function? For Swift, I don't know.
It would leave the switch.
Oh.
Because I used it for table views, basically the list for displaying items. So usually, yeah, I use return for that.
Okay. Yeah, and certainly languages have different idioms. So I'll stop talking about Swift because I don't know about it. So why would we ever want to do this? Why would we ever want to use a switch if it's so viewed and you have to do weird syntax to leave it.
Is it more clear than like using if statements over and over?
Yeah, so that's sort of the most like, sort of like, oh yeah, this is sort of nice, there's fewer lines of code, that's sort of appealing to everyone. But also probably like, why did they add that to the language just for slightly fewer lines of code? I don't know the original motivation of who first came up with it, to be fair. But what it allows, what I have found that makes it sort of useful, oh no, did I leave myself enough? Okay, still kind of want this, but I just need more room. Is that with fall through, what you can do, this is sort of a syntactic trick, but you can do case, curly bracket, and case, square bracket. And then you can do p dot push c, and break. So what on earth is happening here? This is sort of like an OR. This is saying if C is open, curly paren, open, or you know what I mean. If C is any of these three, just keep on going and then just push it once. And we're done. And to that, I mentioned before that notion of a state machine. Again, that's sort of a more esoteric, weird topic. But these things are always, or very often, if you hear state machine, you'll end up seeing a switch. So that's kind of why I feel it's why I wanted to mention it this time.
Sorry, I just managed statements.
Oh, okay. Don't overdo it, I guess. It's just my own. Well, so I think it does work a lot for this question. And it's a nice tool to have in your pocket. I guess the reason why I say don't overdo it is like forgetting the break is a very notorious
I don't
source
like
of
the break, like that's like bothering me
Yes.
personally.
Okay.
Because I know I'll forget it into the fuck my code.
Yeah. There are, depending on your IDE and even language and so on, sometimes it'll at least say like, are you sure you don't want to break here? Languages are starting to get to the point. I swear there's some that instead of break, you have to write, instead of this, it always breaks and you have to write fall through here. Or some other keyword like that. So it's almost the other way around. Why is there this weird syntax? Like, why are we stuck with this, at least for older languages? Do you know what go-tos are? I know this is like, after hours programming languages. Go-tos are a very sort of notorious old programming construct. But it's a bad form of control generally, where you would have like, so basically, it was a syntax where you could just say, I'm trying to think of the motivating example. So a common one would be something like, if you have code where it's like, open a file or open a network connection, right? You want to close your network connection, right? Open network connection. And okay, you want to close, n, right? If n is, and then you do a lot of stuff here. And maybe this is a huge function and you want to kind of leave halfway through. But you don't want to forget to close your network connection. So what you do is you have this thing where you just say, I'm naming this line of code cleanup. And then you would have here, go to cleanup. Never do this. This is awful vestigial stuff. But this is where go-tos come from. This is this. And a switch is actually like a very fancy sort of go-to. See one thing left, but still worthwhile. I'm very opinionated about this. So I hate doing this where it's like, here's this thing, never use it. But like, I feel that I do feel that like someone will mention go-tos and just say no and sort of stuff.
I'd rather you explain it and then say that. Sometimes I was afraid to like talk about it, but like.
Oh, people have like mentioned it in hushed tones.
Not specifically go-to, but it's been a thing I've noticed with teachers. Like, all right, we're not going to talk about this.
Nice. Okay, well, I'm happy to buck the trend, I guess. But yeah, and so like, for instance, so C++ is the language I'm most familiar with. Instead of this cleanup code, because of course you can imagine, you forget to go to here. And then other people can get very creative, and this is just one idiom. You might have a go-to going this way, and things might get really crazy, like ifs and loops and so on are they're human. Like it's sort of easy to reason about. A go-to is pretty simple in the sense that you say, okay, we go here. but it just leads to, the term is spaghetti code, is what it's often called, but just it's kind of hard to read and it's hard to, it's, to say how many ways can I get to here is hard to say, much harder than if you have an if statement. All that's to say, when you implement a switch, you might be tempted, for instance, or so switches are based off of go-tos, and go-tos are very simple. Like they were the first form of control flow versus ifs and loops. And really, these cases are those labels I mentioned. And if you have you might have some variable here, and the compiler will say, no, this has to be a constant. In most languages, I won't say all of them, but in most languages, if you have a switch, the cases have to be, they can't be a variable, they have to be a constant. That's just sort of, try it if it works, but that, and then you have a cool language. But the traditional switch statement, yeah. All right, so that was a fun foray into syntax. And I guess I sort of snuck in a bit of, I promise that this is what I did at least to solve the problem. Of a few steps further into solving this. And how might we finish this case statement, or this switch statement? How might we finish our algorithm? So what other cases might we want to consider? What other values of C do we care about? Yeah. So here, of course, I'm really putting effort. So yeah, the closing characters. Here they are. And what should we do in these cases, right? That's the name. Okay, so p.pop. And well, okay, we remember last time, if p not empty, return false. Otherwise, pop. P.pop. Gotta remember the breaks. Are we happy? This is where, the background music turns minor key, because there's something still lurking in the shadows. And this is why so right now, if you notice, hey, this is just a counter again. I'm sort of jumping ahead because I hit this bug, basically. But wait, if we're treating P, we either make it bigger or we make it smaller, and that's it. So hey, we can solve this just as simply as if it were under parentheses. That doesn't seem, that seems suspicious, I think. Sure.
So how do we check that the thing we're popping, once we see a closing parenthesis, the thing that we're popping is the opposite of what we're currently popping?
So in saying that, I think you've captured the bug that has been lurking in our code. So first I want to make sure everyone, okay. So Alejandro's question was, when we pop, we care about if we're popping, a square one, we should be, or sorry, if we see a square close, we should be popping a square one. So that reflects some issue, some bug. So let's try to make a test case that might manifest this bug, this test-driven development. So simple, warm up. This is good, right? This is good. Oop, not even right. Does that look nice? Oh, okay. Everyone shake their head. Everyone shake your heads. Okay. So this, I know, I wish I had a more consistent font. Here we have open, open, close, close. Push, push, pop, pop. Great. But, uh-oh. We're basically saying, hey, this one is closed by that one. And I guess this is somewhat relies on our intuition about curly braces, or brackets, but that is not what we want. So then Alejandro was saying, okay, we care about when we pop, we better be popping the counterpart to the thing that we're closing. We better, if we're popping because of a round one, or if we see a closed round, we better pop a closed round, open. Does everyone agree that this is a problem and kind of see what's going on? Or is anyone suspicious? Okay, and that is a fair question. And I guess I sort of lied about how we only need push and pop. Okay, I'm gonna drive a little faster, if that's all right. I'm always open to your guys' input if it's like, come on, hurry up here. We might also have something like p dot top, which is just, don't pop it, but just tell me what's on the top of the stack. If we have something like C, or if we have some interface like char pop that this returns the thing that was popped, we can emulate that by saying, temporary equals p dot pop, do stuff with the temporary, and then p dot push t back on. Sort of like taking it off, looking at it, and putting it back on. So long as you don't push anything else in there, it's sort of no one knows. So that's just to hopefully convince you that, okay, we can implement p dot top without sort of cheating. Like this is still a stack. Okay. Or in practice, it's still, every reasonable stack implementation should have something like this, where you don't actually have to pop it.
The one that we had, or that I saw in JavaScript was called peak.
Oh, there you go, peak. Yeah.
Look first.
Yeah, so top, peak, look, might even just be sort of like get, and you give it the index 0 or 1 or whatever. So just to capture the intuition, I think I'll have, if, forget it. Okay. If p dot top all right. Here's another interviewing trick that I'm just going to jump ahead and talk about. Helper functions. We want to make sure if p dot top is this, or whoops, we want to make sure if p dot top is this, we're seeing this. And if p dot top is this, we're seeing this, and so on, right? Like that's what we want to do. We can just have, I'm going to implement a helper function. Char flip. Fix the char. C. And A. We're having so much fun with switch statements. Case. Which way do we want to go? Case close round. So this is what I was asking Zoof earlier. In C and other languages that I'm used to, return returns from the whole function. Or in a switch statement, return returns from the whole function. So you see what I'm doing. You see what this code is doing, right? I gotta ask that question better. But I'm really asking about my handwriting. And then default assert 0. So I've mentioned asserts before. I like asserts. They just crash a program when it's false. So this was a bit of a rush and return space. We should never get it. So what is this doing? This is saying we take a character. This is a function. We take a character. We look at it, and if it's a round bracket, if it's a round closed, we return a round open. And because we're returning, we don't even need to break because we're sort of leaving everything, leaving the switch and function, right? So that's sort of a syntactic shortcut. Oh, because we're returning. So here we were worried about breaks with switches. Yeah. Here we're returning, so we're leaving the switch and the function. Like we would never fall through because we're already done.
So is that why you don't need a break before default?
Yes, because these are the three cases that we'll do something and immediately leave from, and everything else will jump straight to here. And in fact, really, this code will never, ever, ever run. Or I guess we should. That's unfair because sometimes asserts don't quit, blah, blah, blah. So this is just to make it clear that in this switch case, we're either going to end up here, 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 or here, in all cases. Like this is the else.
I have a comment.
Yes, please.
So this, if you think about it, this is where we use the object for. Basically simulate this function where we have a hash map or an object where the keys are the opening, no, the keys are the closing and the value is the opening.
I see. Okay. Yeah, so you can implement this as a hash table as well. Where you would have, is this all, yeah, T of, depending on which direction you care about, T is that. Oh, T of blah is that. And in fact, I guess you could even go the other way. And we could add the other three cases here, like we're really flipping. This is sort of just flipping one direction. When you're all just looking at the board, I can't tell if it's like you're bored or excited or not following. So I'm going to keep it going. But anyway, so if P dot top is the flip of C, P dot pop else return false. And never forget the break. But is that what I want to say? Yes, I honestly wrote in my comments, forgot the break here, R. So I'm saying it's still happening. And yeah, and in fact, when I first went this problem, I try to remember, okay, I write down, here I forgot this as well. So the sort of, just the closing parentheses bug, or your input, I had a bug there. But so I left out the case of, okay, we have to make sure that the stack is still empty at the end. But I guess this was all just a very thorough review of a problem you've seen before. Are there any lingering suspicions or doubts as I will move on to the next one?
What, is this the best case scenario?
Is this is this the most efficient implementation? Or like, can we do some crazy thing with like an integer or whatever? Is that what you're asking?
Like, yeah, is it the most efficient algorithm? Because I get that question from reviews. How do you make this algorithm more efficient?
Yes, that's a fun question.
That's a great question, because if you answer it, and that's the only way you know how to do it, like, say, I don't know, like the 8 here, I don't know, so it's like,
This is so
Yeah.
hard.
So here's a fun, like, this is not cheating, this is actually
yeah,
real.
exactly.
I've been, I guess, this bodyless voice for a while, where you all have been. Yeah, sorry, not distracted. Yeah, so what happens, so I'll expand your question to like, what do you do when anyone asks you, what can we do to make this faster? So sort of this might, I don't know how this would go over, but the honest, like, right answer is if someone in reality says, we want our program to go faster, what you do is you profile it. That's the term, generally it's called. But like there is, depending on language and a lot of other stuff, there's usually some tool where you say, here's my program, and then you run the program, and then it tells you where it spent all of its time. And so a fun sort of answer to that question of how would you make this faster? Say, well, first I would profile it. And then, that's sort of open-ended because who knows where it's spending its time.
Use a set to make it faster. The sets can't take duplicates, so the way I'm thinking about it is no matter what characters we put in, open or closed, it has to be balanced for the set not to reject it. So
I'm not sure if that.
for example, if we put an open parenthesis inside, right?
Well, what?
We can't place another one in.
But for instance, if we have this input,
Exactly. So
we would have, it would be reduced to this, wouldn't it?
exactly, and it will be balanced, and because it's balanced. it has to balance.
You're thinking of let's make it balanced one way or another.
Exactly.
This, so that is, for some problems that makes a lot of sense where you say we have some input, and that's often called like sanitizing. I don't know if that's, where you say like we want to make it kind of more digestible for the rest of our program. But these sort of things, especially, I know this is sort of too shallow maybe, but if it's returning a bool, like we just want to say yes or no. So here we're not fixing anything, we're just saying it's good or bad. So that, in most sets implementations, you'd also lose the order. So you might end up spitting out this, basically. Like you'd have to teach the set that you care about the order. But either way, I don't think that this is just sort of a different problem than what we're trying to solve. And I do want to stress that, like,
Because I was just thinking about using the way you use it, well, the way I use the steps to make sure that an array had unique inputs. You probably use it this way as well.
So there, yeah, so for using a set for unique inputs, you would say, okay, is the set basically the same size as the original array? And that's going back to the yes or no thing. But here, what I was trying to illustrate with this example was like, well, if it'll always return yes, in that case, then now we're answering a different, or with the set, we say yes here, when with this program, we'd say no. So we want to, and that's why I just mean like, oh, it's not, either problem is interesting, it's just a different, both problems are interesting. So going to just, I can jump back to the question of making things faster, or like, how would you make this code better? Is the question better or faster? Usually.
Usually it's the same.
Yeah.
Okay. Better is like, oh, egg comments, or tests.
More efficient usually.
More efficient. So with this, I mean, like, so my background is pretty different from like the web programming or application programming editing you guys are with, so I'm not sure kind of how much overlap there is. So profile, like I wasn't joking about profiling, where it's just, or measuring would be sort of more generic term. Like let's just measure and see where it is. Then another sort of pretty universal or pretty broadly applicable tool is like, well, let's look at the input. If we know that this is a utility, if we're implementing an IDE, we want to implement leak code or whatever, right? The website. And we want to have like a matching parentheses thing. Well, it's like, all right, how big do you think the stack is really going to get? Like how many open parentheses in a row will we really see?
So I'll say there is a chance where you only see open parentheses.
That's fair. Yes. So you might see 10 million open parentheses. And we can cross that bridge when we come to it. But how many, like just, okay, we're asking about this in practice. What happens in practice? How many open parentheses do you probably think we'll see?
There's no constant, like it's just unlimited.
Yeah, but, okay, so that's the very nice and algorithmic thing. But like, come on. How many open parentheses do you have in your code?
My code.
Yeah, like as in that are not, before you start seeing closed ones, right? Like how many contiguous, how big can the stack get if we run it on your code? Like 2 elements, 5 elements, 10? 10, okay. So I asked this question because that might help inform how we would design this. Or for more efficiency, where, okay, if we know our input is usually small, especially if we know it's like an IDE, it's like, okay, we can just, well, let me not get ahead of myself. If it's usually small, then we can say, okay, this stack, or usually the library stack, like the standard stuff, is designed to try to handle everything, including up to 10 million parentheses. It's like, well, maybe there's a better stack we can do. So for instance, usually this is, you guys know about the heap versus the stack? Okay. So when it's basically making a new thing is often more expensive than having a thing just on as a local variable. Like something new, you can kind of return and other functions can look at it sort of more global in a sense. When you have a local variable, it's cheap. So if we know that we're only going to have, so it depends on your language, but usually you'd be able to say something like, well, let's just kind of have a local stack, not allocated on memory. You can't grow bigger than 10, let's say. But we'll do that. And then we can say, okay, we have to check. Maybe it's going to be too big here. And if we're matching parentheses for syntactic highlighting, fine, just don't do it. And that, I'm not saying, and that's great, we don't have to do anything more, interviewer. But like that is, I think, a fair, and the interviewer might say, no, let's figure out something more general. But I think it's a fair thing in reality to say, like if you don't want this thing to slow down at all, You say, I guarantee this is not going to allocate any memory because we're doing it on the local, on the call stack. It's an unfortunate input. And that's the trade-off. That's one thing. And so why do I say that? That's general. If they say make your code faster, you say, okay, let me look more what inputs I expect. And if there is a weird case, there are fancier implementations where it starts out on the stack, or starts out as locals, and then it says, oh, I'm out of room. Instead of failing, it'll say, okay, now I'll start allocating memory. So we'll still do what you want, but it actually, for the common case, that's enough. Do you guys know that word, common case? It's one of those sort of phrases people like to say. But like, yeah, if you're implementing matching parentheses in your IDE, the common case is like, okay, you're gonna have to remember at most like 5 parentheses. That's just an example of how to use the phrase common case. That was a whole lot of random brainstorming. But I hope those are tools that you can take away for very general stuff. That's why I tried like, switch statements. Those are fun. Profiling, measuring, common case input, making those work right. And is there anything else we can do? There's sort of more exotic stuff we can talk about. Yeah, I think that is what is reasonably. That is what is reasonable. And I'll say in terms of, oh, let's just quit early if we run out of room. Like code I work on, we do that all the time. So I'm a little biased. Like we have a lot of things where we want to try something, and like 99% of the time it is very small. And then we say, oh, this is too big. We just forget it. Because speed is very important in our tool. So I'm going to erase this. Okay. Yeah, and there's other general, so I really only have insight about sort of the more generic data structures and algorithms questions. So I can't help you with like iOS questions or anything, but I'm happy to help with these sort of broader questions of like, when an interviewer asks for X, I can at least give you some tools, I hope. So are there any others while I'm erasing?
So I got asked a question in an interview that had to do with stacks. I didn't quite understand if they wanted me to implement the method itself, like make my own method itself, or just code it.
Sorry, with skies? I think I just missed the first word.
No, so they were saying, all right, you have information and you want to push it onto the stack. How will you do it? I said, well, just push it onto the stack. But they kept saying, make a method that does it. So I was trying to clarify whether or not I had to implement my own push and power.
Oh, I see. I mean, obviously I was there, but yeah, I would say if they get to the point of implement, like the method push. What? Oh, they didn't say those words.
They would say those words.
Yeah, okay.
It was just confusing as to what they wanted.
It sounds like they want you to make their own function that does what pop does, but doesn't actually call the method up.
Yeah, but I could have did it, but the way I would have did it, I would have had to make my own list and iterate through the list and assign an area to it.
Yeah, like.
No, because I've done it before. I've implemented my own data structures just to understand how they work. So I could have did it, but.
Yeah, so
And I was asking for verification, but they were, I think there was a communication issue.
Yeah, I mean, if they feel that they know like a word and they really want to make sure you know the word, or they really want to tell the world that they expect everyone to know that word. I don't, sorry, actually for that situation, I don't really have insight. Oh, whoops. All right. That's not much. But any other general questions, or I can move on to the next thing? Okay. Well. And this is a. All right, so here is another question from LeetCode. And again, as always, I encourage you to, like, even after we go over this and you feel you know the answer, like, just do it again. Because kind of just filling it out on your own helps get more familiar with these tools. So here's a question. We have a string that encodes like a user input. So or that expresses user input. So like someone has typed A, B, and then we use a hash mark to mean backspace. So A, B, backspace, C. So on their screen, that might look ultimately like A, C. So the idea is that's sort of the intuition of this encoding of our input. And then we might have another input like A, D, backspace, C. And you think, okay, these are sort of silly, but you can imagine like, if you've all worked with like Git or some other kind of source code, yeah. Like, commit, revert, commit. Yeah. Persuasive, maybe, okay. But the point is that, these are the same string. Even though, or sorry, like the result is the same, even though these are different strings. That A, B, backspace, C is the same as A, D, backspace, right? Like that's the point of backspace. Okay. I'm just setting up like the world that we start caring about now. We have these, we're just going to get we're going to get two strings, S and R. And what we're going to ask is these are just sort of normal strings, and they will have 0 or more hashes in them. And what that means conceptually is, okay, that is supposed to be the idea of like doing the backspace and deleting the previous character. And the question is, given two strings, are they the same when we sort of do that backspace? So we don't actually have to do it. We don't have to delete anything, but we just want to return true or false. So in this case, we'd return true. Because after we take it, even though these strings are themselves different, like we can't just do.
The results are the same.
Yeah. We can't just do return S equals R or whatever. Like that is wrong because these are different. What we want is like return, S with backspaces. Done.
We can solve this using any type of data structure we want.
Yeah. So I mean, I guess it depends on what your interviewer tells you. But this had the little stack tag on it. And right, you can imagine like, oh hey, push. What should we do if we see a backspace? Yeah, I know. Sorry, there's only one other option, right? Push again. I don't know. It's easy when it's a stack if you only have two things to worry about. And I guess that's sort of the key. Maybe I jumped ahead, but that's sort of like the key observation of if the interviewer gives you the hints. Hey, here's a stack, or like we should use a stack for this. And let me just get another example.
Is that how it really works?
What is the thing
like when you press the backspace key?
Basically, no. Sorry. Like, as in, is this in your IDE or whatever? Is there like a stack of characters? Like, I mean, I guess conceptually there is some notion of like, backspace is erase the thing that you just did, but there's not an explicit data. Oh, I guess I don't really know. I would guess there's not an explicit data structure.
I saw this with an array.
Yeah, and so don't.
Yeah, string. Yeah, iterate for it, and then you do a for loop, and then when you get to the hash, you just go like I minus 1, and then delete and then delete that and do then. Well, then you guys keep going into it. You can make two. You can do two sets of arrays.
I think this may be faster.
No, probably faster. With the stack it would be faster.
Well, so I encourage you again because you can write whatever you'd like in LeetCode. So again, I'm being serious. We're sort of like, yes, I think we can. And in fact, there is the follow-up question, which is, can you solve this with? Can you make it faster, basically more efficient than what we're going to do here? Do you mind if I drive a little faster? I never know. Okay, uh-oh. There's a lot of excited nods. That's a bit. So I'm just gonna sort of go through this. And then we can try it with arrays, or you can all try it with arrays at home. The way I solved this was I said, okay, and there was sort of that intuition of like, we can't do this, but it'd be kind of nice to. So I have a helper function. Let's just say, you know, this is C++ syntax, but basically, okay, I'll have A equals process backspaces of S, and B equals process backspaces of R, and return A equals B. So I'm being pretty, like this implementation is pretty explicit. Like I'm going to, of course I haven't implemented this yet, but like here, I'm actually going to be returning a stack of characters. Process. String. No, S. So here I'm using S again, but of course it can be either S or R. Right? Okay. You will be confused soon. And I'm saying is okay, like backspaces, you know, if I see a normal letter, I'll push it on, and if I see a backspace, I'll pop the one I saw previously, because that's what backspace does. And then by the end, I'll have a stack that basically is the string as if we've done the backspaces. You're either really bored or really confused. I can't tell. Let's hope with bored. No, confused. Okay, okay. It's optimistic. I mean, all right. I want process backspace. I'm returning a stack, but really it'll be the same characters in order. But basically, process backspace will turn this into this. That it'll generate a stack with A is the bottommost letter and C is the next letter and so on. And I can give it any string I'd like. And the idea is that the question here is, hey, are these two strings after we kind of do the backspaces? And so I'm just going to explicitly do the backspaces and give myself new strings as if those backspaces happen. I know I keep on harping on the word backspace. But yes?
But if that function is returning a stack, would you be able to do double equal? A double equal B?
Yeah, so that depends on the language, I guess.
Oh,
because I'm a little,
okay.
we can also be like A equals B. Or whatever, or you know, maybe we would need another function that turns a stack into a string. That's tough. Oh. So auto is sort of like var, which I think is in present many languages. But just basically for every character in the string, if the character is a hash, or you know, it's just if the character is not a hash, sorry, stack of char p. Is that legible? I'm just declaring a stack p at the top of this function. Then for every character in our string, if it's not a hash, I will just push it on. And if it is a hash, then I want to do backspace. And what do I mean by do backspace? I mean that, well, if P is empty, a backspace does nothing, right? That's sort of, I guess, you know, maybe we want to throw an exception, but in this case, we'll just do nothing. Otherwise, we'll pop previously. Oh, wait. Okay. Ta-da! I know, that was a rushed, I'm sorry. But let's review this quickly for a second. So here, this is a different way of writing it, but it's that idea of we have a sequence. So a string is a sequence of characters. Go through every character. And, you know, sort of usually, when C is not a hash mark, we just push it on. And that's us just sort of keeping track of it. And then it's exactly when you see a hash mark that if we can, we'll pop it. And do people believe that this sort of captures the idea of what our string is trying to express? Is there some lingering doubt or some lingering sort of like, this doesn't sound? Is there an input about which we might be suspicious? Like a test input?
I guess I'm not too clear on how do we make sure we're popping the character preceding the hash.
So let's say with this string. And you're saying, how do we know we're really going to get rid of this one
Yeah.
and not like this one?
Yeah. Because are we, we're iterating through your string and then, okay.
So here we're iterating through the string left to right, you might say, like from the first character. And you know, at any point halfway through the loop, pretend we haven't seen any hashes yet. It's like, what's the top of the stack? Right, like if we just finished processing this first character, A, what's the top of the stack?
A.
Yeah, and then if we just finished processing B, what's the top of the stack? So the stack looks like A and then B, and then when we see a hash, which one do we pop?
Hash. Oh, wait.
Well, so when we see the hash,
Popping the top.
yeah, we pop the top, and this is why the question is tagged stack, I guess, where we want to pop the thing we saw most recently. And as it happens, the stack perfectly sort of captures that idea of top of the stack is the thing we saw most recently. Is that believable? This is really exercising, like this loop only does what we want because it's a stack. If it were like a queue, we would get garbage. You know, like we would not get what we want. But I like that question because it's like I opened this up saying, oh, stacks sort of sometimes capture exactly the intuition of an algorithm we're trying to implement. And this is sort of the other way around. It's like, oh, we have this, I think, sort of I hope, a natural idea of like, oh, we want to kind of delete the previous character we've typed. And then we think around it, oh, it just kind of magically happens that the stack does what we want. So, maybe that was two things. I need a speedometer or something. So now that was kind of quick. Do we have other questions about this?
So you said there was a follow-up question on how should you make this more efficient?
Yes.
I cannot envision such.
So the short, or the clue, I guess, is that we will not, here we're spending a lot of time and space making this stack. Like we're basically copying our input string into a new stack. Like, right, if there were no backspaces at all, we'd just end up with the same string, just sort of in a stack form. And so really the question is saying, can we do this comparison without having to copy the string? That's another way. That's sort of I wouldn't say it's a hint, but that's sort of taking the big step back so we don't feel constrained by using stacks. So the answer is on the website. I don't want to just say it. And I'll confess, I just was like, whatever, and I clicked the button to see what it was. I'm trying to think of a hint. I can't think of a hint that will, other than just like telling you what it is, which I can afterwards. I just don't want it, case if all of our other viewers at home are.
So that other solution will be, it won't require a stack.
That is correct. That we can solve this without explicitly building a stack. Okay. Are we ready to move on to the next question? At which I have a fun and engaging rant. Okay, I'm going to erase this. Or I will, all right. Before I erase it, I'll just point out that here's another helper function. Helper functions are great. And there's often a temptation of like, especially on the elite code or those web online ones where it's like, here's the function you're supposed to implement. You think, great, I'm going to implement that function. There's no reason why you can't implement helpers. And like here, right, you know, that avoided a lot of copy and paste. That I could just call this function twice instead of like pasting it. All right. Here's a fun rant, and for those on your computer, you can bring it up if you'd like to bring up the question on LeetCode. I said this is an exercise in understanding overly complicated problem descriptions. So here's the third question, the overly complicated. Oops. Really, are we like locked in here? Secure. This is the panic room. Except for the giant double door, whatever. The quasi bag. Sorry, what was I saying? Yeah, so this third question, if you look on Slack, I think I added a comment that this is an exercise in like really complicated ways of phrasing the question. So first, how should I do this? So here's what's written down. And I'm doing this because this happened, I have a grudge against these sort of people sometimes. But like, people learn sort of a very like mathematical or a neat syntactic way of describing something, and then they use it. They say, oh, well, surely everyone knows this, and if they don't, then I get to show that I know it. So, that said, here's how this problem is phrased. Sorry? Oh, no.
It's like a real world example, just think of this stuff. Very applicable.
Oh, wait, was that a question or a statement?
No.
Okay.
At least I.
Yes, and there's that notion of like, you know, you come to dislike the person you were before. It's like, maybe I was once guilty of this, so this is my penance. So anyways, the question as is written, a valid parentheses string is either empty or is this plus a plus, and hey, if you guys all get this, like great. Then I misjudged how difficult, or something. So a valid parentheses is either empty, this, or a, open plus a plus close, or a plus b, where a and b are valid parentheses strings, and plus represents string concatenation. So far, so good.
Okay. Can A and B are any characters?
No.
Quite literally A and B.
To answer your question, here's how it's described, where A, B are valid parentheses strings. I think I misspelled parentheses, but whatever. This is the definition of valid parentheses. I don't know how to spell string. So valid parentheses string is either blank, open plus a plus close, or a plus b, where a and b are valid parentheses string. Now, if this is intuitive, great.
So, is that the whole question?
No. Or that's the first half of the definition. And it says, so let's do this for you. What does this actually say?
I'm slightly confused.
Yeah.
Because if A and B are valid parentheses strings, then that means A or B itself has to be a pair of parentheses strings.
Yeah.
It can't just be one.
Yes.
It can't just be an open or just a close.
So this is a particular way of representing strings, like this sort of, like almost arithmetic. And one of the key parts of it is it's recursive, which I know we've seen other ways, but this is not. This is recursively like mathematically. It's not like there's function calls, right? And to kind of spell this out, okay, what's happening? And if I say a valid parentheses string, what are some explicit examples? Like, what have we been doing all this time?
One open parenthesis and follow that closing parenthesis.
So which one does that match up here?
Hey. Oh wait, which one does it match up to? Like,
Yeah, and which is, I guess, as it's phrased, it's not really a one-word answer, or like there's not really a
the
straightforward.
second one would be the closest.
Yeah. So it'd say, okay, like this kind of, all right, well, we have this and it matches with this, and this, and it matches with that. But then, we have to have some kind of A. The A, we can say, we have three choices. A is either this, or this. And let's choose this one. It's the empty string, so then we do get what we want. This is a little hand wavy, I know. But this sort of syntax, frankly, doesn't come up that often, but it came up in this question. And if you go through, I'm sure there are other ones in lead code or coder skills or whatever they are, where someone has learned about this sort of, I'm being a little fair. I feel that someone was very excited to share this sort of syntax they learned. And it is like valid, it's just sort of distracting. So anyways, here's another fun, valid parentheses string. And how might we describe it with these tools? Well, what we can do, I know that was just sort of rhetorical, as we say, or in fact, here's another way of understanding it, visualizing it. This is, 1, 2, or 3. So if we have this, we say this is a 2, right? This is this, plus A, plus.
Okay, now we're getting somewhere.
Plus this. So, that didn't actually quite respond, but someone got it. But this is saying, okay, this is like a 3, right? We're saying it's this thing plus this thing, just like here, A plus B. And then what is this? Well, this is just like a 2, and this is just like a 1. So this feels like a whole lot of energy just to sort of say something I feel is fairly intuitive. Parentheses at work. Yeah, please.
If we consider a open parenthesis a valid parenthesis string, would it still work?
So if we said, is this by itself valid?
Yes.
Oh, you're saying if we add that as a valid one?
No, well, if that is valid, if a parenthesis is valid, then number 3 will apply on the simplest case, which is open and closed.
Yes, but then also that would mean that this by itself is a valid parentheses string, which is probably not what we want to express.
Okay.
So this, they don't actually say the problem. And to be honest, again, this is not something that will really come up in your day-to-day. Except have you ever had to parse JSON, write a JSON parser?
Yeah.
Oh, really? Jeez.
Well, not right.
Who did it?
But use one.
Yeah, okay. Well, so that would be one heck of an injury question, a very, very big. But for this sort of weird syntax and this thing kind of expanded to the nth degree or whatever, this is often how programming languages or file formats like JSON, it's not a file, but are specified. It's called a grammar, like English grammar, only this is a formal grammar. And it's a way of specifying strings. So it's this is again just something that hopefully won't come up because it's not too often, but if someone might say a valid JSON thing is this plus a body, and body is maybe a key and a value. There's it has a special sort of syntax. It's its own programming language, this sort of stuff. But it is sometimes used to talk about file formats. Or if you get data over a network connection, It might say, oh, it's in this format according to this sort of stuff. It's a bit much for an interview question, frankly, in my opinion. So do we feel we have overcome this strange hurdle? There's one no. And earlier, yes, so let's roll with that. So all this is saying, really, is that a valid parentheses is the thing that we know what a valid parentheses are. Great. We haven't gotten to the question yet. Question introduces a new word. A valid parentheses string S. So that's just saying S is some valid, it could be huge, many parentheses, all interleaved, but like in a valid way, in the way that you expect, is primitive if it is non-empty. What does non-empty mean? Don't overthink this, it's just kind of a weird way. Yeah.
It has at least one character.
Yeah, so they're like, both of those are true, and like, what is non-empty? It's like, okay, it's basically everything except this. It's like, all right, primitive if it's not the empty string, and there does not exist a way to split S into A plus B, where with A and B non-empty valid parentheses strings. So what is a primitive parentheses string? By this definition. So a primitive parentheses string S is anything that's non-empty, so it has to have some parentheses, and it can't be broken into A plus B. So hold on, what's A plus B again? What's an example of A plus B?
Or string or two sets of parentheses.
Yeah, so if, and I know I'm reading this and it's like, really you should be, in an ideal world this will also be written down for you. But yeah, it's saying A and B are neither empty. These both have at least some parentheses. And so it would look something like this. Or it would look, much more complicated. And in fact, even though, hey, here it is again, this could be B, this could be, for instance. Oop, that's not A. That's A. So saying S is anything that's not, it doesn't look like that. So what's a parentheses string that doesn't look like that? It doesn't have these two contiguous, sort of unseparated pairs.
Could you repeat the definition of a primitive string?
A primitive parentheses string is not empty, and it cannot, and it's any valid parentheses string, except ones that can be broken into A and B, like this. So this is not primitive. This is not primitive because of this little gap, Oh gosh, I can't do anything. This is not primitive because, there's a gap there and there. We can choose either one, and it's sort of enough. So what are some strings that are primitive?
I'll say open parentheses. Close.
Is that it?
Yes.
Well, I would say that in our effort to avoid having this sort of compound stuff, we have forgotten to be valid. So in fact,
it has to be valid.
oh, okay. Well, that's what I said.
Okay.
So you're suggesting this.
So if A in the primitive parenthesis string has to be a valid parenthesis string that cannot be broken into A and B.
Yeah, it can't be it can't be A and B, but it could be A or B. That's what I think it's saying. Because without the gaps, it can be like infinite. So it can be open, close, close, but it can't have the gap.
Yeah. So this is good.
Yeah.
This is good, and so on. And yeah, and so this phrasing things as negative, where it's saying like a primitive string is a primitive string is anything that's not, or like a thing blah 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 that is not. For some reason, people really like phrasing things that way, and it's just sort of like I think recursion is a lot harder, but it's sort of like the same idea of like, it's just sort of unintuitive.
Which reminds me of like the SAT.
Yeah, the analogies, or no. You still have analogies? But yes, the sort of like word games where it's like, feels like a double negation. Here's a tricky-ish one. But like, oh, here, we have those compound ones, but it's safely wrapped up.
Oh, so that
this
would
one-
be valid as long as it's wrapped.
Yeah, so this is also sort of primitive.
Okay.
Oh gosh, well, you can do this one. So the last part of the question. Given a valid parentheses string S, consider its primitive decomposition. Where it's saying S equals the primitive decomposition where S equals P1 plus P2 plus P3 plus ... plus Pn. Leaves K. Where P sub I is primitive. So what does that mean? Yeah, people are just giving up now, which is fine, because it's 9 p.m.
Isn't it meaning like find the lowest En that S can be? So wouldn't it be P2? Because it's open parentheses, close parentheses. That's like the simplest form of what S can be.
I mean, in a sense, we don't want to do anything excessive, but it's not quite talking about that. This is saying given some S, so there's some fixed S. Like, let's make it a little interesting, very complicated. So like here's S, and it's saying let's break S up, and this is not even in code, but just sort of conceptually. Can we define S as the concatenation, because again, plus is concatenation, of smaller strings, where each of those are primitive parentheses. Or, sorry, yeah, a primitive parentheses string.
Say that again?
Yeah. So, here's this S. Can we express S as adding up primitive parentheses strings?
So,
Yeah.
What's the return value?
So yeah, so there's no really a function here. This is again this sort of, and maybe this will be frustratingly like, of course, but this is what conceptually is sort of happening. You're saying S is this, which is, we would agree is a primitive string. This is a primitive string, right? And you can imagine it sort of iteratively. Don't worry, I'll write it again. We're saying, all right, this one's not primitive as it is because of this, for instance, right? We say, okay, but this one is primitive. So you can say, okay, it's this plus the rest. Say, oh, wait a second. This also isn't primitive because of this. So we break that up as well. So we say, okay, this. And then we look at them and we say, okay, these are all primitive. And so that's just, this is not code, this is just, though it will finally relate to the question. This is just sort of a way of talking about strings. And so, frankly, primitive, like the word primitive, like it's used a lot. And it's like, it's fine to say, oh, these are how I define a primitive parentheses string, but I wouldn't say it's like universal. Like I've never heard of it before. Yes?
Question.
Yeah.
Are we still using stack scopes?
Yeah, so we haven't even gotten to the question. But yeah, what the question will be is, or what the question is given this sort of string, sort of remove the outer parentheses of every primitive component. So here, what we would want to do is we want to ultimately return the string I know I'm being a little syntactically vague, but as in like here we strip out this and this, and this and this, and this and this.
Another thing, for my language, string is not a primitive, it is an object.
Yes, so
It's been confusing every time I say string and primitive, it's like, it's not registering.
well, and that's sort of, it's an overloaded term. That they're using it just sort of as an adjective. They're not trying to relate it to a programming language. Sorry, I should have prefaced with that.
No, that's
Yeah, like you might as well just replace the word like simple. So we'd say a simple parentheses string is one with blah 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 blah, and then a simple decomposition. And so I chose this question in part because when you talk about like file formats or parsing, the question is hopefully more natural. But like this idea of like, oh, we can break strings up in this way. That's sort of the conceptual building blocks to a lot of it. Because really, if you go the other way, this is sort of a recursive definition. Like if you look up on the definition of a JSON object, or like a valid JSON string, I'm sure there's a lot of weird edge cases that have come in real life. But it will be defined in some much bigger version like this. So I just thought this would be a fun way or a smaller introduction to that sort of idea. The actual question, which is given this string, return a different string where the outer parentheses of all of the components are removed, is a little contrived. But it is a fun and advanced application. I mean, it's similar in spirit to the other two questions we saw. It's just a little trickier just because, or I think it's a little trickier just because there's sort of a few more moving pieces in your head to keep in mind. I encourage you all to try it. And as always, you can email me or ping me on Slack or whatever. Any questions or celebrations or concerns?
So this sounds like a recursive algorithm. Is that true? The solution will involve recursion?
The way I implemented it did not require recursion. And in fact, just as a bit of an outline, I feel that it is a natural presentation of the solution is still just actually going through the string once, just like how we did with the matching parentheses at the beginning. Obviously it's different, but the way to think about the problem, the way the problem is defined, it's sort of defined in a recursive way. So that's where I certainly see where you're coming from. Yeah, and I guess I like your question because there's this idea where sometimes problems can be phrased in a very recursive way, and you might not want to solve them recursively, and also vice versa. So I'm afraid we don't have time to actually go through this one, but I have now. I hope I do, as always, I encourage you guys to look at these later. And I hope that, if you go through and even read this question again, like, okay, you kind of can get a little bit more familiar with the language used. Because it's not super common, but it's one of those like technical things. Some people like to talk that way.
Thank you.
Thank you.
Yes, thank you all for coming. Yes, I don't know when.
If we don't email you, will you go over this next week?
These same questions?
Yeah, well, not these same questions, just to answer this.
Oh, sure. I guess I usually just like bring new questions each time. There's no reason why I can't.
Maybe I'll just bring it.
Yeah, so always do it yourselves. But yeah, if we want to go over it, that'd be great. I'd be happy to do that. We can stop broadcasting now.